Hello everybody. Once again I am here with you for the another point or the another session that is related with the critical constants. So we are looking for the second unit, real gases and their behavior. Now critical constants are already we have seen what is to be as an critical point is to be there. The such a point where at below that temperature that all the gases are gas is going to be converted into liquid, and that temperature exactly is nothing but to be the called as a critical temperature. And at that point whatever be the pressure, that is called critical pressure, and whatever be the volume at that point, that is nothing but to be your critical volume. And this is point where it is to be as an critical point is to be there, and these all are critical constants are to be there, and what exactly the relationships are to be there, that we will see in this session. So moving forward, as we all aware about that, already in the previous session we learned that one was correction for the ideal gas or the real gas equation, that is P plus A by V square into V minus B is equal to RT. And now this is quite interesting to see the correlation as far as van der Waals equation, and exactly the critical constant points are critical constants are to be there. And also the boil temperature, in boil temperature we learn that at the boil temperature is where PV and V sorry PV and P having the constant ratio, and that particularly obeying the Boyle's law is to be there. At that point the dP by dV is nothing but to be zero, and that point is nothing but to be called your basically inflection point, point of inflection is to be there, where the this PV and P is going to be the constant, and that is dP by dV is going to be zero in that case. And as far as the pressure, volume and the temperature at critical points are already known as a critical constants, and we are interested here to find out the relationships with the corrected van der Waals equation of state is to be there. So again the boil temperature relationship, as we know that dP by dV is equal to 0. So all that factors we are considering for getting this critical constants relationships are to be there. So it is quite interesting to learn, see what is exactly it gives us, that is about the critical constants values are to be there. So here this P plus A by V square into V minus B is equal to RT. This one is the van der Waals equation of the state. And a little bit trigonometric adjustments, if you look at this is nothing but to be if this goes V minus B goes to the right hand side, then it will be RT divided by V minus B we can write. Again this P plus A by V square is to be there, if it goes to the right hand side it will be minus towards right hand side, if it will go right hand side it will become minus A by V square. So I can write this relationship P is equal to RT by V minus B, uh, RT by V minus B minus A by V square is to be there. So you can write it as a equation number 2 also, and this is to be as an equation of the state, van der Waals is as a 1 also. So for our simplification we are giving the notations or the equation numbers for this. So this is what the variation or the trigonometric adjustments are to be there. The equation is same, we are just simulating or the adjusting it in a proper way to get the P's value. Now differentiating P with respect to V, that's what the boil temperature dP by dV, that's where we are looking for. And if we differentiate this equation number 2 with respect to V, then what will happen, it will become dP by dV, sorry, it will become dP by dV left hand side. So is equal to, now differentiation for this right hand side, it is simply as V minus B power is 1, so it will be again minus of RT divided by V minus B square will be there. So square will be there. Here minus minus will be plus, and A by V square is there, so 2 will come forward, it will be upward, 2A by V cube will be there. So 2A by V cube. This is what the differentiation methods, and we will give it to be equation number 3 for this equation, where the dP by dV is nothing but to be minus of RT by V minus B whole square plus 2A by V cube is to be there. So now, as at the critical point, we know that this dP and dV at that point will be become to be as an 0, and that's why this at the critical point dP by dV is 0, and the temperature at that point we can call it as a critical temperature, and that's why it is notifying with the TC, and the volume at that point is nothing but to be critical volume, and it is notified with the V suffix C. And putting these values in equation number 3, dP by dV will be 0, so remaining part will be as it is, only the notations are going to be changing. For the critical temperature it is Tc, and for the critical volume it is Vc, V suffix C is to be there. So this relationship will become minus of RTC, that means to be suffix C, divided by Vc minus B whole square plus plus 2A divided by Vc cube is to be there. Just notifications regarding the at the critical point, it is called critical volume and the critical temperature, and that's why we are changing this. Now this suppose in this equation, if this minus of RTC upon Vc minus B whole square, if it will go to the left hand side, it will become plus, and the new relation will be RTC by Vc minus B whole square is equal to 2A divided by Vc cube is to be there. So this is equation number 4. In that case, with this differentiation, we have this relationship. So moving forward, if this relationship dP by dV I can write is equal to, I have the equation number 3. Likewise, this dP by dV is equal to RT minus of RT divided by V minus B whole square plus 2A divided by V cube is to be there. This is what the equation number 3 is to be there. And if suppose I am again differentiating equation 3, means double differentiation part is to be there, and at this stage again the things will go in this way. Likewise, I will show you. No doubt, dP by dV, that means to be d2p by dv square it will become. So double differentiation again ddv of this, so that's why d2 d2p by dv square is equal to, again this minus will be there, that will become plus, and this 2 will go forward upward, that 2RT divided by V minus B whole square, here it will become cube, so this will be 2RT divided by V minus B whole cube is to be there. Here it is plus, it will again become minus, this 3 will go upward, and 3 into 2 6, and 6A it will become divided by V cube, that means V4, V raised to 4 it will be there. So new relation will be d2p by dv square is equal to 2RT divided by V minus B cube minus 6A divided by V raised to 4 is to be there. So this is what the new relation for the double differentiation of the equation P is equal to there, and equation number 3 is differentiated with respect to volume. Now again at the critical point, d2p by dv square is always to be again 0, as dp by dv is equal to 0, d2p by d2p by dv square is also going to be 0. And no doubt at the critical point, whatever be the temperature, it is called critical temperature Tc, and the critical volume will be Vc, and 0 is equal to, again we will write 2RT divided by V minus B, that means to be Vc minus B whole cube minus 6A divided by Vc raised to 4 is to be there. Again, if this minus of 6a by vc raised to 4, it will go to the left hand side, it will become plus. मग त्याच्यावरून मला काय लिहिता येते, 2rtc डिवायडेड बाय vc मायनस b क्यूब इज इक्वल टू 6a डिवायडेड बाय vc raised to 4 is to be there. So this is equation number 5. So this is what the differentiation of equation number 3 and double differentiation of equation number 3 is to be of previous one will be giving us two relations, equation number 3 and equation to be as an equation number 5 in addition to that. So now from the equation 4 and the previous one is the 4 and the 5. Now from the equation 4 and the 5 we have the new relations, that is to be dividing equation 4 by 5. So let's look at what happens for this case. This is equation number 4, that is rtc by vc minus b whole square is equal to 2a by vc cube, and equation number 5 is 2rtc divided by vc minus b whole cube is equal to 6a vc raised to 4 is to be there. So now 4 is divided by 5. मग आता rtc divided by vc minus b whole square ह्याला जर 2rtc बाय vc मायनस बी होल क्यूब यानी जर डिवाइड केलं तर vc मायनस बी क्यूब वरती जाईल आणि 2rtc खाली राहील. मग ह्या केसमध्ये काय होईल, म्हणजेच ह्याला इंटू काय येणार आहे, इथं vc मायनस बी क्यूब डिवायडेड बाय 2rtc मग rtc हा rtc कटला, 2 रिमेनिंग राहिला आणि वरती आहे vc मायनस बी क्यूब आणि खाली आहे vc मायनस बी स्क्वेअर. मग हा क्यूब आणि हा स्क्वेअर इथला जर समजा कटला तर एक vc मायनस बी वरती राहतो आणि डिवायडेड बाय 2 आणि तोच आहे vc मायनस बी बाय 2 उरलेला. आता what happens towards this case as far as this right hand side for this equation 4, 2a by vc cube 4 by 5 करायचे into मग काय होईल, vc raised to 4 divided by 6a will be there. मग हे बे कबे बे त्रिक 6 a गेला 3 रिमेनिंग आणि vc raised to 3 आणि vc raised to 4 एक vc वर राहील. मग उरला कोण, vc divided by 3 will be there. So vc divided by 3 is equal to vc minus b by 2 is to be there. So आता तिरकस गुणाकार जर केला तर 2vc is equal to 3vc minus 3b is to be there. This will like this. आणि हेच जर समजा आता मी हा 2vc जर ह्या साईडला घेतला तर प्लस आहे तर मायनस होईल आणि हा 3b इकडं मायनस आहे इकडं घेतला तर प्लस होईल. म्हणजे मग 3vc मायनस 2vc इज इक्वल टू 3b आणि 3vc मायनस 2vc 1vc will be there. So vc is equal to 3b. So we have the value for the critical volume, that is vc is equal to 3b is to be there. So in this case this is what we found exactly the value for the critical volume. Now substituting this vc in equation number 4, as equation number 4 is in equation number 4, if we are putting these values of vc and vc is nothing but to be 3b. Now what is the equation number 4, already we have equation number 4 here आणि ह्या 4 मध्ये जर समजा मी vc ची व्हॅल्यू जी आलेली आहे ती vc ची व्हॅल्यू आलेली आहे 3b. जर समजा ही व्हॅल्यू पुटअप केली मग इथं काय होते, इथं vc ऑलरेडी इक्वेशन 4 मध्ये बघा rtc डिवायडेड बाय vc मायनस बी होल स्क्वेअर इज इक्वल टू 2a बाय vc क्यूब. मग आता ह्या ठिकाणी rtc ॲज इट इज vc मायनस बी, आता vc ची व्हॅल्यू किती आहे 3b आली, मग ही 3b मायनस बी 2b त्याचा स्क्वेअर म्हणजे काय होईल 4b square and that will be rtc divided by 4b square. म्हणून इथं काय आलं rtc divided by 4b square. आता तेच राईट हँड साईडला 2a डिवायडेड बाय व्ही सी क्यूब. व्ही सीची व्हॅल्यू किती आहे 3b आहे आणि 2a ॲज इट इज. व्ही सी क्यूब म्हणजे काय 3 त्रिक 9 त्रिक 27 बी क्यूब 27 बी क्यूब इज देअर. 2a divided by 27 b cube is there. 2a divided by 27 b cube is to be there. So we have the relationship equation number 4 will be 2a divided by 27 b cube is equal to RTC divided by 4b square is to be there. So this is what the new relation we have, and with this we can find TC is equal to. ह्याच्यावरून आपल्याला TC काढता येते. मग TC जर काढायचं असेल तर काय करावं लागेल, हे R डिवायडेड बाय 4b हे जर इकडं गेलं तर काय होते 4b स्क्वेअर इकडं जर गेला या ठिकाणी तर मला लिहिता येते हे 4b स्क्वेअर इथं डिवायडेड बाय R. मग ह्या ठिकाणी जे काही आर टी सी जो आहे हा टी सी इज इक्वल टू आता इकडं 4b स्क्वेअर गेलं. 4b स्क्वेअर वरती बी स्क्वेअर आहे खाली बी क्यूब आहे. मग इथले 2 आणि इथले 3च्या ऐवजी 2 गेले, उरला एक बी. 27 ॲज इट इज, हे 27 ॲज इट इज. हा आर इकडं खाली आलाय म्हणून हा आर. बी उरला म्हणून बी. आता वरती काय 4 गेलेलं आहे, 4 into 2 that is 8a. म्हणून what is the value for the TC? The TC is having the value that is 8a divided by 27 RB is to be there. So this is what the TC, that means critical temperature relationship is to be there. So the another one remaining, that is we have now critical volume and the critical temperature relation is to be there. Now we are interested to find the critical pressure is to be there. So to get the critical pressure we have to put these values of Vc and Tc in equation number 2. जर समजा इक्वेशन नंबर 2 जर तुम्हाला लक्षात असेल तर इक्वेशन नंबर 2 आपल्याजवळ होतं P इज इक्वल टू आर टी डिवायडेड बाय व्ही बी मायनस ए अपॉन व्ही स्क्वेअर इज टू बी देअर. याच्यामध्ये जर समजा तुम्ही बघताल तर व्ही सी आणि टी सीच्या जर व्हॅल्यू पुटअप केल्या तर त्यामध्ये हे पी होणार आहे पी सी, it will be there. R will become to be as an RT will become RTC divided by VC minus B minus A upon VC square is to be there. So this will be like this equation is to be there, and putting these values of TC. मग आता TC ची व्हॅल्यू काय 8A divided by 27 RB. मग ह्या TCच्या ऐवजी ह्या ठिकाणी 8a by 27 RB हे जर पुटअप केलं तर बघा इट विल बी 8AR divided by 27 RB इन ब्रॅकेट काय V मायनस बी आहे, पण V म्हणजे VC. VC ची व्हॅल्यू आहे 3B, 3B minus B 2B. So the remaining value will be 2B. So we have the relation that is 2B is to be there. Again minus of what is that a by v square minus of a v square म्हणजे vc square. vc ची व्हॅल्यू काय 3b आहे म्हणजे काय 9b square होईल. so it will become 9b square. so if you look at this is to be a upon 9b square is to be there. so this is what the values we have taken into account. आता याच्यामध्ये जर समजा केअरफुली तुम्ही जर बघितलं तर 8 AR upon 27 RB minus A upon RB into 2B minus A upon 9B square is to be there. So simplifying this again we will get the new relation that is to be. आता याच्यामधून जर समजा 9B स्क्वेअर इथं जर बघताल तर हे 9 हे B आहे, हा इथं B आहे म्हणजे B इंटू बी बी स्क्वेअर. इथं ए आहे, इथं पण ए आहे. आता 27 इंटू 2B ह्या 27B स्क्वेअर जर समजा मी ह्याच्यामधून ए अपॉन 27B हा पर्टिक्युलरली पार्ट ॲज एन मी जर कॉमनली घेतला तर पी सी विल बी हॅविंग द व्हॅल्यू दॅट इज टू बी. ह्याच्यामधून जर समजा मी इथं सिम्पली जर समजा बघायला गेलं तर दिस आर will be covered with this R. that means only r will get cancel. आणि इथं जे आहे 8a divided by 27b square is to be there. now 8a च्या ऐवजी आता ह्याला पण समजा बे एक बे आणि बे दोन्ही 4 असं जर केलं तर that is also the one way, that is it will become 2a upon 27b square is to be there, and it is minus of a upon 9b cube is to be there. So in this case आता इथं जे उरलेली व्हॅल्यू आहे pc is equal to 2a divided by 27b square, ये b square है, minus of a upon 9b square is to be there. जर समजा मी ह्या इक्वेशनला 3 ने डिवाइड केलं आणि 3 ने मल्टिप्लाय केलं तर काहीच इक्वेशनमध्ये फरक पडत नाही. पण ही काय होते, ही होते 3a डिवायडेड बाय 9 त्रिक 27, that is 27b square. So it will become to be as an likewise this, and with that case we have the values that is to be related with to be this case, and if we solve this one it will give us 3a मायनस, हे जर तिरकस गुणाकार केला तरी पण सॉल्व करता येते. त्या पद्धतीने जरी सॉल्व केलं तरी पण आपल्याला जी व्हॅल्यू मिळणार आहे करेक्शन करून ह्या पद्धतीने आणखीन सॉल्व करून, तर आपल्याला जी व्हॅल्यू इथे मिळेल दॅट विल बी a upon 27b square will be there. So this is what the value that is about the PC is to be there. So with this case we have the relationships for the TC, VC and PC is to be there. So this is what the way to find out the critical constants relation. There is one another term which is called as a corresponding states, and corresponding states are nothing but to be related with the when the two gases are to be said to be corresponding state with each other if the ratio of their actual pressure, volume, temperature and critical pressure, critical volume, critical temperature are same. हा रेशो दोन्ही गॅसेसचा ए आणि बी गॅस असे समजा आहेत. मग लेट्स कन्सिडर दॅट P1, V1, T1 is nothing but to be the pressure, actual volume, actual temperature of gas A. Similarly, PC1, PC2, TC1 is nothing but to be critical pressure, critical volume and critical temperature for the gas A, that is, and P2, V2, T2, that will be the actual pressure, volume and temperature of gas B, and PC2, VC2 and TC2 are nothing but to be critical pressure, critical volume, critical temperature of gas B. When these ratios are going to be constant, then that is called corresponding states of each other. So what will be the relation it should have? It should have these relationships, that is P1 upon PC1 is equal to P2 upon PC2. Similarly, V1 upon VC1 is equal to V2 upon VC2. Again, T1 upon TC1 is equal to T2 upon TC2. So in this case, we can say the corresponding states, both the gases are corresponding states of each other. म्हणजे त्यांचं जे काही क्रिटिकल प्रेशर, क्रिटिकल व्हॉल्यूम, क्रिटिकल टेम्परेचर आणि ॲक्च्युअल प्रेशर, व्हॉल्यूम, टेम्परेचर ह्याचा रेशो हा एकमेकांच्या ह्या रिलेशनशिपमध्ये असेल तेव्हा आपण म्हणू शकतो देर आर टू स्टेट्स, करस्पॉन्डिंग स्टेट्स of each other. Again, thank you for joining this session. Be at home and be safe. Thank you.